Hello, everyone. Thanks for joining. My name is Brandon Leach, and I'm a software architect at Autodesk. And I'm joined by Paul Roberts, who's a solution architect at AWS. Today, I'm going to be talking about how we're using Spinnaker at Autodesk, a bit about how we decided to use Spinnaker, and I'm also going to talk about a new declarative GitOps interface Autodesk is building for Spinnaker. And then Paul's going to share some new Spinnaker projects AWS and Autodesk are collaborating on. So first, a little bit about Autodesk. We make software for people who make things. We're a global leader in design and make software for the architecture, engineering, construction, entertainment, and manufacturing industries. If you've ever driven a high-performance car, admired a skyscraper, used a smartphone, or watched a great film, chances are you've experienced what millions of Autodesk customers have been building with our software. And here's a small example of Autodesk products you may have heard of. There are many more. This is just a small sample, but AutoCAD, I'm sure most of you have heard of this one. This is the first Autodesk product that I ever used back in 2000. It's used by architects, engineers, construction professionals to create 2D and 3D drawings. There's Fusion 360, which is a cloud-based CAD CAM tool for collaboration for collaborative product development that combines industrial design, mechanical engineering, simulation, and machine tool programming. And then BIM 360 and Revit are used for designing, collaborating, and around making constructed things like buildings, bridges, roads, etc. And then there's 3ds Max and Maya, which are used for 3D computer animation, modeling, simulation, and rendering. The area that I work in is called Forge. Forge is Autodesk cloud development platform. The Forge platform is a set of web service APIs that allows our users to tap into their design and engineering data that they use to automate processes, connect teams and workflows, and visualize data. There's an internal and external aspect of Forge. Many Autodesk products are built using Forge's internal APIs and services, and then there are APIs that we expose to our external customers. Autodesk customers use Forge to integrate their products into their own environment, typically by grabbing, translating, presenting data from our applications. Some examples of this are data management, accessing and managing files and data in Autodesk Cloud Storage, or design automation. The design automation API allows you to access automation capabilities of Autodesk core products as cloud services. So any task that you can automate on your desktop application can now be automated at scale using the Design Automation API. Model derivatives and viewer. These allow you to extract data and convert between 2D and 3D models. There's a lot of different file formats across our industry and our products. And Forge provides a service to convert and view all these file formats across platforms. Reality capture, you can create 3D models, textured meshes, point clouds, ortho photos from your drone, laser scans, or handheld camera photos. Here's a link to some of the amazing things our customers have built with Forge. It's really impressive. So this platform is powered by a very large cloud presence in AWS. And the deployment and management of these cloud services and infrastructure that power Forge and Autodesk is very important for our operations. The team that I work with builds the internal tools and automation that engineers in Forge and Autodesk as a whole use to create service, manage deployments, and operate their cloud services. Enter Spinnaker. Recently we made the decision in Forge to replace multiple sets of in-house deployment tooling with Spinnaker. One of the main reasons we decided to make this move was the size and the strength of the Spinnaker community itself. The Spinnaker community has become really strong in recent years, and it's quickly becoming industry standard open source CD platform. It also really caught our eye that the major cloud providers are contributing to Spinnaker. This provides a certain amount of safety and longevity to this decision. Another main reason we decided to use Spinnaker is the elegant abstraction it provides between your deployment logic and the underlying reference runtime. There are many levels of abstraction you can implement between an engineer writing code and underlying cloud primitives. And like where and how you implement these abstractions is key to operating efficiently while also having flexibility. You know, this is a powerful abstraction because it allows you the flexibility to adopt and experiment with different reference runtimes without having to replatform. You know, decisions around these runtimes are highly strategic. Like for instance, the decision to use Kubernetes, AWS, Azure, GCP, or the decision to use multiple different providers at the same time. This abstraction allows you the flexibility to make these decisions and pivot without the burden of having to change your deployment platforms or your user experience. In Forge, we utilize the EC2. We utilize the EC2 provider for VM workloads, ECS for containerized services, and Lambda for our serverless applications. So the application definition files. You know, one of the patterns that we took from one of our existing tooling, our existing sets of tooling, was a declarative interface called an application definition file, or ADF for short, which allows our users, our customers, GitOps workflow for managing all aspects of their services. You know, when we began implementing Spinnaker, we decided it was important that we allow for the management of all service components in the ADF. This includes everything like observability, infrastructure, deployment, pipelines, etc. You know, we sought to eliminate the toil of our internal customers having to design their own release processes and pipelines. You know, I've seen this before with Spinnaker in my previous company where we had many different pipelines to designs, which effectively did the same thing. This makes it really difficult to release new Spinnaker capabilities and have them easily adopted by your customers because each customer has to figure out how to fit the new features into their own implementation, right? So instead, we decided to build upon predefined best practice pipelines and infrastructure configurations, and also offer some limited extensibility to allow our customers to customize as they see fit. Another problem that we sought to tackle with the ADF was allowing our customers to manage their data stores and other supporting infrastructure within the context of their service deployment in Spinnaker. Right, this gives our users the same interface to manage databases, load balancers, security groups, IAM, etc., along with their application deployment. So let's look at a very simple example ADF, right? It has three main sections, and generally it's worth noting that the ADF generally resides within the service code repository itself. So the first part is service configuration, right? This is where you declare your environment-specific service configuration. You know, these are values that are used to hydrate a template that are then loaded by your application at runtime. Infrastructure. This contains the environment and region infrastructure definitions for the application, right? It can contain things like IAM, security groups, load balancers, databases, basically anything that can be managed with Terraform. It's worth noting that these values, and we'll get into this a little bit more later, but these values are essentially Terraform TFRs with references to the modules for which they're supposed to be used with. So yeah, all the examples I'm using here in the ADF are for our VM or EC2 pipeline. So this section, the EC2 part contains all of the stuff needed by Packer in the big step of your pipeline. And then pipeline site YAML, right? This contains the release requirements for your services that are fed into a pipeline template and used to create your Spinnaker pipeline. So let's look a little deeper into pipeline YAML and some of the extensibility it offers, right? You know, this file contains all the requirements for the service release process. So triggers. Here's where you can configure specifically how your Spinnaker pipeline is triggered. In this example, the service is configured to be triggered from a specific Jenkins job on a specific Jenkins server. You know, in notifications, you can configure where Spinnaker will send all the messages related to your deployment status. Right now, you know, we support Slack and email notifications. Type. So this is important. We have a pipeline template, a reference pipeline template for each runtime. So there's an ADF interface and a pipeline template for front-end applications, EC2 applications, ECS container applications, and Lambda serverless applications. So you specify the environments which you want your service deployed in, right? So this is the environments that you put here. This is where your service is actually deployed. In this case, it's deployed in dev, stage, and production environments. And the stages are rendered in the pipeline in the sequential order that they appear in the file. So regions. For each environment, you can specify the region your service needs to be deployed. So as you can see here in development, it's only deployed in one region, but then staging and production environments are actually deployed in 2 regions. Region sequencing is a feature we just added that allows you to decide on the multi-region deployment strategy you want to use. So currently we support 2 options. Like serial is where each region is deployed in the order that appears in YAML. And then parallel, where all regions are deployed at the same time. So you can also decide on other things that you want to activate in your pipeline, right? So like here, it specifies that they want manual approvals rendered into each stage in the pipeline. You know, this is a simple example that uses manual approvals, but there's other optional stages that can be activated, like testing stages to run like Jenkins jobs or a testing container, or deployment strategies like canaries. You know, in order to automate this process, we've built a Python application which consumes an ADF, right, and then renders the needed Terraform files and Spinnaker pipeline needed to deploy the application and infrastructure. The YAML that comes out of the infrastructure section of the ADF is turned into TF vars, which are then base 64 encoded and rendered into the Spinnaker pipelines as artifacts, along with the reference to the Terraform modules for which consumes them. Here's an example of an EC2 service which has been rendered by Skipper from an ADF. You know, in the artifact section, you can see the base 64 encoded TF vars, which came from the ADF, along with a reference to the Terraform module they'll be used with. As you can see, there's an apply infrastructure stage before the deployment stage. This is a special stage type called Terraformer. Terraformer was provided by our Spinnaker vendor, Armory, which allows you to automate the planning, approval, and execution of Terraform in Spinnaker pipelines. And it has a really nice integration with the UI. So like here you can see the Terraform stages, downloading the modules needed, hydrating them with TF vars, and then TF vars from the pipeline, and then creating all the infrastructure, the ALB, the S3 bucket, the security groups needed for the application. You know, Terraform has some really neat features, like it'll do a Terraform plan, and if there's no changes, it'll just pass the stage. Or if there are changes in the TF plan, you can configure it to wait for approval before executing. So Skipper uses a data templating language called JSONet to render the pipeline and load the rendered pipeline into Spinnaker, and then triggers the pipeline. You know, JSONet came out of Google. It's like a simple extension of JSON that allows for things like variables, functions, conditionals, arithmetic, etc. So yeah, we've just completed our first iteration of the ADF with Skipper, and we're in the process of onboarding customers at Autodesk. I'm super excited about this project. The team who has done a really amazing job who has implemented this. So now I'm going to change gears a little bit. You know, we realized that there were some features that we needed that were missing in Spinnaker when we started looking into implementing it, and started having discussions with Paul Roberts at AWS about these gaps. I just want to say they've done an amazing job coming alongside us and helping us with these problems. And now, I'll hand it off now to Paul to talk about some of the Spinnaker related projects that we're working on together.
Yeah, thanks, Brandon. You know, first I just have to say, you know, the work that Autodesk is doing with ADF and Skipper, I'm completely blown away. I think this is something that is really going to help move them forward, and it's just a really cool abstraction that they've built. You know, with that said, I'm thrilled that we're collaborating, you know, with Autodesk. They came to us and they had some really interesting things that they would like to see with Spinnaker. And Brandon, if you want to go to the next slide, I'll dive into that. But you know, some of that revolved around the work that we initially did about 24 months ago with Lambda. So for those of you in the community, that may or may not be aware of the Lambda integration, this is something that we, again, dropped about two years ago. And first what we did was we created an all-new cloud driver. And so there really was no functions compute primitive within Spinnaker. And so we spent a long time working with the community and actually rolling this out. And that was in December of 2018 when the cloud driver actually was merged. So when we rolled that out, we actually saw some decent adoption from several customers, but it really didn't get going until later that year, where we started looking at integrating deck, which is the UI component. And once we had the deck integration in there, now users could do full create, read, update, delete type functionality with Lambda. The missing piece here was adding a Lambda pipeline stage. So Brandon and his team, they came to us and said, look, we're really interested in using Lambda. We're heavy users of Spinnaker. How can we collaborate and update the UI so it becomes more functional for us when we're using these ADFs, etc. So the first thing that we're going to be doing is we're going to be updating the deck UI. We're going to be building out a new pipeline stage for Lambda, which is going to be super cool because one of the main use cases we see with Lambda today is that people frequently use it as glue code. So, and what I mean by glue code, this is a way that you can kind of pass different operations between services or between your internal code pipelines, if you will, and Lambda can kind of stick everything together. And then the other really important piece is that in Lambda itself, there's a way to do there's a way to do deployment strategies, and this is like your blue-green type deployments. And the way you can do this today is using aliases. And so as an example, within Lambda, you deploy different versions. So as a developer, I can have my version 1, 2, 3, 4, 5, whatever you have. And before you go into production, you can actually weight how much traffic is going to be pushed towards, how much Lambda invoke traffic is going to be pushed towards a specific function. So the nice thing here is again, using a standard blue-green approach, you can direct traffic to your existing deployment, and then you can roll forward to your new production deployment when you're ready. And that's in there today. We just need to get the UI updated. So that's really important. Next slide, please, Brandon. So the second request, working with Brandon and his team, which was a great call out, was that any customers that are using Spinnaker at scale, and specifically with Autodesk, they have their ADF usage. But what I'm seeing from other customers is there's this whole concept of environment as a service. And when I say environment as a service, this means that customers want to add a lot of accounts for their respective use cases. And when they do this, they need to also add those accounts into Spinnaker, so the cloud driver can pick up the new AWS accounts. Well, in order to do that, you have to restart the account, the cloud driver component, every single time you add a new AWS account. So what we're looking to do is, can we build some additional tooling inside of Spinnaker, and can we create some workflows that a customer can say, here's a list of the accounts that I want to onboard. Will Spinnaker pick those up and automatically begin consuming those accounts? And I think the end result of building out this functionality is that for customers that are trying to onboard 100, 200, 300 plus accounts, it doesn't have to be hundreds, but if you have a large amount of accounts and you don't want to be restarting Cloud Driver every few minutes or every few hours, it just picks up the new accounts. It's going to be a huge benefit, and ultimately you'll be able to deliver applications at a much faster pace. So with that said, there's a lot of work that we're doing here with both on the Lambda side and on the ECS side for this account automation piece. But at AWS, we're not stopping here. There's additional work going on with Spinnaker. As I mentioned, we've been doing this now for about 2 years. There's a lot more work going on. My colleague, Claire Liguri, she's going to be presenting at Spinnaker.Live as well. There's a lot of work coming out of the ECS team, which is fantastic. The Lambda team is actively contributing as well. So there's a lot of work and there's a lot of collaboration coming from AWS. So please stay tuned. And I'm super excited to be working with Brandon and his team to make Spinnaker better for the entire community. Brandon, back to you.
Awesome. Thanks, Paul. So I also just want to mention, yeah, I'm really excited about our collaboration too. I'm really excited to get these features into open source Spinnaker. They're going to be a big help for us. I also want to mention Autodesk is hiring. So here's a link. Come check it out and come join us. Thanks, everyone.